Hello math students. Today's video is lesson 2.5 powerful tens. In 2.5 we are going to use what we know about logarithms to learn how to solve logarithmic equations and exponential equations. So while what we're doing today is only going to be base 10, the things that we are learning can be applied to any base. So on number 1, I give you a table and I want you to figure out the missing x values. So table A, the y values are generated by using the equation y equals 10 to the x. So if I want to know for this first missing x what y is equal to, I'm going to plug that in for y, so 50 equals y, and then I don't know what x is equal to. What I can do now is I can rewrite this in exponential form, in logarithmic form, and so it's going to look like x is equal to log, and I'm just going to say log 50. Technically, I could put a 10 down here, but I don't need to with base 10. So now that I have x by itself, all I have to do is plug log 50 into a calculator. When I plug that into the calculator, I get that x is equal to 1.699. I can do the same thing when y equals 100. Plug 100 in for y. Rewrite this in logarithmic form. I can say x is equal to log base 10 of 100. This is one that I could plug into a calculator, but I know that 10 to the 2 is equal to 100. So the answer to this log is just that exponent, and so I can say x is equal to 2. On table B, it's pretty much the same thing except for I have this 3 that's part of 10 to the x. So if I'm doing the first entry on this table, the 0.3, I would say 0.3 is equal to 3 times 10 to the x. And then I need to get the 10 to the x by itself. In order to do that, I'm going to divide both sides by 3. So those 3's cancel out right there. And so I'm left with 0.1 is equal to 10 to the x. At this point now, because the 10 to the x is alone, I can say x is equal to log of 0.1. Plug that into my calculator. I get x equals -1. I'm going to do the same thing for the 94.87 and the 1503.56. So 94.87, I'm going to say is equal to 3 times 10 to the x. I'm going to go ahead and divide both sides by 3. So when I divide 94.87 by 3, I get 31.623 is equal to 10 to the x. And then I can say x is equal to log of 31.623. When I plug that into my calculator, I get that x is approximately 1.5. It's 1.5 and then a bunch of zeros and then another number. So I'm just going to say 1.5. So the last one that we're going to do is this 1503.56. I'm going to say 1503.56 is equal to 3 times 10 to the x. Divide both sides by 3. I end up with 501.19 is equal to 10 to the x. Rewrite that as a log. X equals log of 501.19. When I put that in a calculator, I get x is 2.7. Or pretty close, it ends up rounding to 2.7. So for each of these tables, I want to know what equations could have been written in terms of x for each of the rows that are missing the x values. So for table A, I had that y is equal to 10 to the x. What I wanted to do is I'm wanting to rewrite this as x equals something with a y. So I'm just going to rewrite this in our log form, x equals log of y. So now if I had wanted to know when y equals 533, what is x equal to? I can plug 533 directly into the y. We can do a similar thing for table B. For table B, I had y is equal to 3 times 10 to the x. I want to get x by itself, which means I need to first get rid of that 3. So I have that y over 3 is equal to 10 to the x. And then rewrite this in log form. X is equal to log of y over 3. So these two tables that we just did had an equation with an exponential function. The next two tables we're going to look at are tables with log equations. So on D, I have y is equal to log of x. So if I'm going to start with this -1, I'm going to plug that in for y. Then I'm going to solve for x. So remember, this is a base 10 log. So I'm going to put this in exponentially form. So I can say 10 with an exponent of -1 is equal to x. And then I can plug this in my calculator and I get that x is equal to 0.1. Or if we use rules of exponents, I can say that it's 1/10. So x is either equal to 0.1, which is the same as 1 over 10. We would do the same thing if y equals 1.6. I'm going to rewrite this in exponential form. So I can say 10 with an exponent of 1.6 is equal to x. Plug that into my calculator. I get that x is approximately 39.811. And I'm just rounding to 3 decimal places here. So it's 39.811. Table C is similar, except for I have this x plus 3 inside of the log. So if I start with the first entry on the table, I can say -2 is equal to log of x plus 3. The only thing I have on the right side of the equation is the log, so I can go ahead and put this in exponential form. I can say 10 to the -2 is equal to x plus 3. And then in order to solve for x, I need to subtract away that 3. So I'm going to say x is equal to 10 to the negative 2 minus 3. And when I plug that into my calculator, I get x is equal to negative 2.99. We'll do the same kind of thing for the next two entries on my table. I have y equals 0.3. So I can say 0.3 is equal to log of x plus 3. Rewrite in exponential form. 10 to the 0.3 is equal to x plus 3. Subtract 3 from both sides. Leaves me with x equals 10 to the 0.3 minus 3, which when I plug that into a calculator, I have x is approximately equal to 1.005. And then we'll do the exact same thing for the last entry on this table. I'm going to say 3 is equal to log of x plus 3. Write it in exponential form. 10 to the 3 is equal to x plus 3. Subtract 3 from both sides. I have x is equal to 10 to the 3 minus 3, which is equal to 997. So we're going to do the same thing with these equations as we did on the equations we had on A and B. So what equations can be written for each of the rows that are missing x in the tables above? So on table D, I had y equals log of x. I'm just going to rewrite this in exponential form, and I can say x is equal to 10 to the y. That would be my equation on D. For E, I had y is equal to log of x plus 3. I'll rewrite it in exponential form. 10 to the y is equal to x plus 3. Subtract 3 from both sides. Leaves me with x is equal to 10 to the y minus 3. So on the first two tables, I gave you exponential functions, and we wanted to solve for x. So what we did on each of those is we started by isolating the exponential piece. So I'm going to say start with, do that, isolate the exponential part. So that's just the 10 and the exponent. Or if it gave me a different base, if it was 2 to the x plus 4 equals 7, get the 2 to the x plus 4 alone. After I do that, this is the big thing, is I'm going to rewrite in log form. So that takes the x out of the exponent, and now I can just solve for x. We can use a similar strategy to find solutions to equations that have logarithmic functions. So I'm going to start with my first step as isolate. When I say isolate, I just mean get it by itself, the log. So I want to have just a log on one side of the equation, and then I can have whatever else on the other side of the equation. After I do that, I'm now going to rewrite it in exponential form. And now my x is no longer stuck inside the log. So I can just go ahead and solve for x. So the last part of 2.5 is just practicing solving equations. So I just have ones that are exponential. So I have 10 to the x equals 1,000. First thing, make sure my exponential piece is isolated. It is, so we can move on to our second step, which is to rewrite it in log form. So I can say x is equal to log of 10,000. And I could plug that into a calculator, or we know that 10 to the 4 is equal to 10,000. And so x is equal to 4. We'll use the same process on number 5. I have the exponential piece isolated. So I'm going to write this in log form. X is equal to log of 125. And then I go ahead and put that into my calculator. And when I do that, I get x is equal to 2.907. On number 6, I have my exponential piece is isolated. So I'm going to put this in log form. I can say x plus 2 is equal to log of 347. I need to get x by itself now, so I'm going to subtract 2 from both sides, which leaves me at x is equal to log of 347 minus 2. I plug that into my calculator, and I get x is 0.54. On number 7, I need to get this exponential piece by itself. In order to do that, I need to get rid of the 5. So I'm going to start by dividing both sides by 5. So I'm left with 10 with an exponent of x plus 2 is equal to 0.05. I'm going to then rewrite this in logarithmic form. And then solve for x. Subtract 2 from both sides, leaves me with x equals log of 0.05 minus 2. And then I plug that into my calculator, and I get negative 3.301. Number 8, I already have the exponential piece isolated. So I can write this in exponential form. Negative x minus 1 is equal to log of 1 over 36. I need to get x by itself, so I'm going to add 1 to both sides. And I have negative x is equal to log of 1 over 36 plus 1. I'm going to go ahead right now and plug the right half of this equation into my calculator. I have negative x is equal to 0.556. And then I'm going to divide both sides by a negative 1 to isolate the x. So x is equal to 0.556. And then last but not least, I have number 10. So I need to isolate this 10 to the x plus 2. So I'm going to do that by dividing both sides by a -1. If I go and try and put this into log form, I have x plus 2 is equal to log of -16. This is a big problem because you cannot put a negative number into a logarithm. This is because no matter what my exponent is right here, I can never have a negative number. So I'm going to go ahead and say that this logarithm has no, or this equation has no solution.